This head bigger than your duku. Stubborn academy, we like to shoot too. One bullet I say chale, it go make you poo poo. On a bicycle, so take your trailer. And I'll be famous like Mali and the Whalers. I know they kiss us, fuck all your favors. Nobody bigger than God, Jehovah.
Hello everyone, welcome to today's class. So today we are going to be looking at chain rule of differentiation. So we know that in differentiation there are different methods we can use depending on the type of function we want to differentiate. So today we are going to see how we can use the chain rule and what type of functions are used for the word chain rule. So here we say that this rule is used to differentiate composite function. So composite functions are functions that have other functions in them. So we call it functions of functions. So for example, y equal to 2x plus 5 all raised to power 3 is a composite word function, because we know we can bring out 2x from here plus 5. We can also bring out 2x plus 5 raised to power 2 and so on. So this becomes a composite word function. So y equal to sine 5x is also a composite function, because the simplest form of the trigonometry here should have been sine x. But instead, we have an additional value there, which makes it a composite word function. So when we talk about composite function, what we are looking at is functions that have other functions embedded in them. So same with this, y equal to square root of 4x minus 3 is also a composite function. The simplest form should have been 4x minus minus 3, but we have a square root on it, so that makes it a composite word function. So now we know what a composite function is. We can now make use of the chain rule formula to differentiate any function that is a composite word function. So we have dy dx is the formula we use to solve for the chain rule as dy all over du dot du all over dx. So I will show you how we are going to use this formula to solve the composite function. So we have some questions here. We have to find the derivatives of the following. So we want to find the y dx of each of these function here. So clearly, if you observe these functions, you will notice that they are all composite functions. So let's start with the first one, y equal to 2x plus 5 raised to power 3. So we have y is equal to 2x plus 5 all raised to power 3. Now the first step I will do is I want to try to set what we have here, the simplest form, to be equal to u. So that means I will say let u be equal to what we have in the bracket as 2x plus 5. Now we are going to look back to the question which we have y equal to. So what we have here is 2x plus 5, which we have set to be u. So we can now use this as u, then raised to power 3. So we have this. Now I'm going to differentiate what we have here with respect to x. I will differentiate y with respect to u. So if I differentiate, I'll be having that du all over dx with respect to x will be equal to 2. So if you differentiate this function, this is a constant, so it will go out. If you differentiate 2x, you have 2. So 2x will disappear. So what will be left is 2. So now you have gotten the u, the x. Now can we differentiate this other function, the y, with respect to u this time? So we are differentiating y with respect to u. Now in differentiation, we know for simple polynomials like this, we move the 3 over to this place. We are going to have 3u. Now we subtract this 3 with 1. So it will be It will be 2. So we have this. So dy du is equal to 3u raised to power 2. Now we go to our chain rule formula. It says the y dx is equal to dy du dot du the x. So we have that the y the x is equal to dy du dot the u, the what, the x. So if we look at this, the y, the u has already been gotten as 3u squared. So we have 3u squared. Now times, this dot here means times. So we have the u, the x. The u, the x is given us now as what? As 2. So you can see clearly that 2 can multiply with 3. So we'll be having 6u what? Squared. So when 3 multiply with 2, we have 6. Then we have u what? U squared. So now this should have been the answer. But remember, this u was not in the question. So we are the ones that introduced u to be equal to this so that we can simplify and make use of the chain rule formula. So we are going back to the value of u to substitute so that the answer will be 6. Then u is what? Is 2x plus what? Plus 5. Then we have what? All raised to power what? 2. So this gives us our dy, the what? The x. So that's how we get the derivative of the what? Of the function. So with this, we have gotten that. Now let's look at the second question. So in the second question, we have that y is equal to x squared minus 1 all raised to power 5. Now we want to set our u to be equal to what we have in the what? In the bracket, which is x squared minus what? 1. Now you can now see that the original function becomes, everything here is u all raised to power what? 5. So we have this. Now we can differentiate for this. If I differentiate u with respect to x, so we have du dx. So that means we'll be having, if we differentiate for this, 2 will move over to this place. We have 2x, then we subtract with what? With 1. We have what? 1. Then if you differentiate a constant doesn't have what? X on it. So it will give you what? 0. So that's why we are left with 2x. So the derivative here is 2x. Now we are also going to do the same. Differentiate y with respect to u. So if we differentiate y with respect to u, 5 will come over to this place. We'll be having 5u. Then we subtract 5 with 1. What will remain is what? Is 4. We have done the what? The derivative. So now we go back to our chain rule. So chain rule says that the y, the x is equal to the y, the u, dot the u, the what? The x. So that means my dy dx is equal to the y, the u, dot the u, the what? The x. So here we have gotten our dy, the x, the u, rather, which is 5u raised to power what? 4. And we have the u, the x, which we have also gotten as 2 what? 2x. So you can see that 2 can multiply with 5. We'll be having 10. Then this is x is here. Then we have u raised to power what? 4. Now we know the answer cannot be with u because u was what we set to be equal to x squared minus what? 1. So anywhere I see x squared and u, I put x squared minus what? 1. So this will be 10x. Then this becomes x squared minus what? 1. All raised to power what? 4. We have gotten the what? The derivative. So the derivative of this function is equal to 10x, bracket open, x squared minus 1 raised to power what? 4. Now let's do the third one. We'll do it over to this place. Alright, so for this we have y equal to square root of 4x minus 3. Now we want to differentiate. So you can see that from here this is the same as writing that y is equal to 4x minus 3 and raised to power 1 over 2. So whenever you have this, a square root, we can see this as the power is 1 over what? 2. So that is the same as this. So in this case, we set 4x minus 3 to be our u. So we have u is equal to 4x minus what? 3. So that implies that y will become u raised to power what? Half. So now we are going to differentiate u with respect to x here. So if you do that, when you differentiate a constant is 0, differentiate 4x, we'll be having what? 4. Now, we do the same way. We are going to differentiate y with respect to what? To u. So if we differentiate half, we move over to this place. We are going to have half u, then we have half minus what? 1. So that's the differentiation there. So if you subtract half with 1, we are going to have negative what? Half. So half minus 1 is minus 1 over what? 2. So now we have this. We remember that our chain rule says that the y, the x is equal to the y, the u, dot the u, the what? The x. So can you see that our dy, the u is the whole of this? So which is half of u, half of this. So this will be giving us 1 over 2 u raised to power 1 over half, then minus 1 over 2. So then multiply it with du dx. Our du dx is equal to 4. So we have this. Now you can see that 4 can multiply with your half, so that all we'll be having is 4 can go here, 2 can go here, 4 can go here, will be 2. So we'll be having 2 times 1, which is 2u half. So we have this. Now, in our elementary indices, we can see that whenever we have a power that is negative, it can be written as 2 is here. So we write this as 1 all over u raised to power what? Half. So they are the same. So 1 all over u raised to power half is the same as u raised to power minus 1 over what? 2. So now 2 can multiply here. We'll be having 2 all over. Then u is set to be 4x minus 3. So we have 4x minus 3 all raised to power what? Half. So we have this. Now, in standard form, we can decide to write this as a square root, just like we converted from square root to power half. Whenever we see power half, we can rewrite it towards square root. So that will give us 2 all over square root of 4x minus 3. So that gives us our dy dx. So that is how you differentiate functions like this. So let's look at the fourth one, and see how we can differentiate it. We have y equal to sine bracket open 5x plus 2. So we want to find dy dx. So here we are going to set everything inside the function to be u, which is 5x plus 2. And we can see that the original function becomes sine. Everything here is now what? U. So we have this. Now, if we differentiate u with respect to x, we are going to have 5 from the differentiation. So 2 will go out, then differentiating 5x, we have what? 5. So if we differentiate y with respect to u, we are going to see that the derivative of sine u will give us cos what? U. So when you differentiate sine u, you have cos what? Cos u. So we have this. Now, the chain rule says dy dx is equal to dy du dot du the what? The x. So we have our dy du. Dy du is cos u. So we write cos what? Cos u times we have du dx. Du dx is what? Is 5. So we have this. Now, this 5 is the one here. Yeah, so this 5 will multiply this 1. It will give us 5 cos what? Cos u. And from our substitution, we saw that u is equal to 5x plus what? Plus 2. So if you substitute, you have 5x plus what? Plus 2. So that gives you our dy dx using the what? Chain rule. So we have seen how we can differentiate functions using what? Chain rule. And remember, chain rule is only used for such composite what? Functions. So in the next video, we are going to go to the next method of differentiation, which is the product what? rule, and we are going to see the type of functions that are used to differentiate with what the product what rule. So see you in that video. Thank you.